This is day 1 of Unit 3, Section 2. We're going to do textbook section 3.1. So first we're going to talk about all the different words that kind of represent the same thing. So when we talk about polynomials, we talk about their solutions. Right? So the solution of a polynomial. But another word for the solution of a polynomial could be its root. Right? That's another word that means the same thing. If I was looking at the graph, I would call each of the solutions or the roots the x-intercepts. Right? When you have a graph, the x-intercept is going to be one of the solutions or one of the roots. And another word is zero, and we call it a zero because the y value is 0 for all of the solutions, for all of the roots, for all of the x-intercepts. If we wanted to solve by graphing, we would graph the function, either by hand or with software, and we would identify the x-intercepts. Right? Wherever it crossed or touched the x-axis, that would be considered one of the solutions. We're going to focus right now on solving by square roots. So if the only variable, or parentheses with the only variable, is squared, then we're going to isolate that term and take the square root of both sides. We're going to make sure we include both the positive and negative root or solution for each one. So we're going to solve each of these. We're going to write our answers as reduced radicals and also as decimals rounded to the hundredth. So here, if I want to undo x squared, I would be taking the square root of both sides. So the square root of x squared is x. I want to include both the positive and negative answer. And then I'm looking for the square root of 4, right? I know that 4 is a perfect square, and the square root of 4 is 2. So this is a reduced radical, and it's the decimal. We don't have to do anything else. That is our answer. All right, for the second one, x squared equals 25. So take the square root of both sides. The square root of x squared is x, and the square root of 25 is 5. So it's going to be positive and negative 5. All right, for x squared equals 48, when I go to take the square root of both sides, I would get, if I used a calculator, it might give me the decimal equivalent, which right away is 6.93. So that's one way I could write my answer. That's the decimal answer. But I can also reduce this radical. And when we say reduce the radical, we mean we're going to rewrite it so that 48 has a perfect square in it. So I could use my blue sheet, green sheet, whatever color it was, to find out what numbers go into 48 that are perfect squares. So I know that 1 and 48, right, neither of those are perfect squares. 2 and 24, neither are perfect squares. 3 and 16. So 16 happens to be a perfect square, right? It's 16 times 3 is what I really get when I have 48. So when I look at this, I'm going to take the square root of just the 16, which is 4, and since I can't take the square root of 3, it's going to stay inside the radical. All right, so that would be my reduced radical answer. All right, same thing when I go to do number 4. If I just did it on a calculator, it might give me the decimal equivalent of 14.14. But if I wanted to reduce this radical, right, 1 and 200, 2 and 100. So 200 can really be rewritten as 100 times 2. So I can take the square root of 100 and get 10, but the 2 is going to stay inside. All right, let's look at a few more together. For these, the x or the part that's being squared is not alone. So we want to get it alone before we do anything else. So here, pretending this was just a regular x, I would have to get rid of the minus 31 first. So we'd plus 31. So now I have 4x squared equals 80. I would divide both sides by 4. So x squared is 20. And now I have the x squared isolated. So here I could take the square root of both sides. I couldn't do it at any point up until now. So that means if I got the decimal, it'd be 4.47. But I could also reduce this, right? 20, right? 1 and 10, 1 and 20, 2 and 10, neither are perfect squares, 3 doesn't go in, 4 and 5, and 4 is a perfect square. So if I looked at 20 as really 4 times 5, then we would have positive or negative. Square root of 4 is 2. Leave the square root of 5. Right? But the only thing that was different about this one is we started with the x squared not being alone. So let's look at B. Add the 9 first, so 3x squared equals 9. Divide both sides by 3, so x squared equals 3. I can go ahead and take the square root. So x is going to equal positive or negative. This cannot go any further. The only things that multiply to give me 3 are 1 and 3. So it stays as the square root of 3. And if I wrote it as a decimal, that'd be 1.73. In part C, not just the x is being squared, the entire set of parentheses is being squared. So I need to get the entire set of parentheses alone. I could do that by dividing by 4. I can't distribute the 4. Can't distribute if there's a power, but I could divide both sides by 4, so that I'm left with x minus 2 squared equals 100 divided by 4 is 25. So the entire side here is being squared. So I can actually take the square root of the entire side now. And the square root and the squared cancel each other out, and I'm left with what was inside the parentheses, which is x minus 2. When I take the square root of 25, I get plus or minus 5. If I were to add this over here, plus 2 and plus 2, it's a positive 2 plus or minus 5. So that's 2 plus 5 and 2 minus 5. So x equals 7 and x equals negative 3. Right? Two different answers there. Just like there was a positive and a negative as two answers here, these happen to be different numbers this time instead of positive and negative of the same thing. So in D, same idea. I'm going to get rid of the 2/5 first by multiplying by the reciprocal, 5/2. When I multiply by 5/2, I get 10 on this side. So we have x plus 3 squared equals 10. I could take the square root of both sides. So x plus 3 equals plus or minus. I can't reduce the square root of 10, so I'm going to leave it as the square root of 10. If I were to subtract 3 from both sides, I'd have negative 3 plus or minus the square root of 10. And when I get to problems like this, I probably am not going to turn them into decimals. You can if you'd like. So what I would do is I would take the square root of 10 and then add to it negative 3. And then I would take the square root of 10, turn it into the opposite sign, and then add to it negative 3. And if I did that, I would get 0.16 and negative 6.16. But really, when we get to an answer like this, we can leave it like that. So you go ahead and try these three, pause it, and then you can check your answers. All right, so check your answers. Number 3 was plus or minus 3. Number 4, you could turn this one into a decimal because we already had a decimal underneath the radical, right? Square root of 7/2 or square root of 3.5 is plus or minus 1.87. And then number 5, we got 4 plus or minus the square root of 5. All right, if you wanted the decimals for that one, it would have been 6.24 and 1.76. All right, before we go on to the next kind, we're going to look at a word problem. So when an object is dropped, its height h in feet above the ground after t seconds can be modeled by the function h equals negative 16 t squared plus h sub 0, where h sub 0 is the initial height in feet of the object. For a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. So 50 feet right here is where we're starting out, which means that would represent our h sub 0. So for part A, write a function that gives the height in feet of the container after t seconds. That means I'm going to take this thing, but I'm just going to replace h sub 0 with 50. Part B is asking how long does it take the container to hit the ground. So when it hits the ground, the height is now 0. So that means I'm going to put 0 in for h, and I'm going to solve this. So I'm actually going to add 16t squared to this side. I'm going to divide both sides by 16. And I'm going to take the square root. So when I take the square root of 50 over 16, I get plus or minus 1.77. So we know that it can't be a negative time, right? Can't have a negative 1.77 seconds, so it's the positive. That's our answer. All right, the next type we're going to look at is solving by factoring. So in order to solve by factoring, the equation must equal 0. If there's a GCF, factor it out. And now that we are solving by factoring, we don't really need to see the GCF in our answer because it's gone, right? Unless the GCF was a variable, the number divides out and it goes away. After factored, we're going to set each of the factors equal to 0 and solve them. So here's our first one. We have 4 terms. We're going to factor it by grouping. So right, 1, 2, 3, 4. We split it down the middle. The first 2, we could take out 8x squared. And when we take that out, we're left with 6x plus 1. For the second 2 numbers, I could take out a -7. And we're left with 6x plus 1, right? Always good that they match. So that means my answer is 6x plus 1 times 8x squared minus 7. So each of these is considered a factor. Anytime I see an x, it's a factor. So 6x plus 1 is a factor, so I'm going to set 6x plus 1 equal to 0, and I'm going to solve. All right, subtract 1 first, divide by 6, x is -1/6. We could turn that into a decimal if we want, or we can leave it as the fraction. The other factor was 8x squared minus 7. So I'm going to set that equal to 0. Right? Add 7, divide by 8, and then we're going to take the square root. Remember, we're going to get both the positive and negative answer, and when I take the square root of 7/8, I get 0.94 approximately. So those are my answers for this. Notice I had 1, 2, 3 x values. My power was 3. All right, so you go ahead, try this one, pause it, and check your answer when you're ready. All right, so when I factored this by grouping, my factors were x plus 5 and 2x squared minus 3. So my solutions were x equals -5 and x equaled positive and negative 1.22. Remember, we could also factor if there are 3 terms and the a value, or the number in front of the x squared, is 1. And when we do that, we find out what multiplies to c and adds to b. So in this problem, notice it's already equal to 0. So this is my c value, this is my b value. We're looking for what multiplies to -32 and adds to -4. So we know it's going to be a positive and negative if it's a negative. So that would be like 1 and -32, 2 and -16, 3 doesn't go in, 4 and -8, and I've already found it, right? 4 times -8 is -32, 4 plus -8 is -4. So that means my factors are x plus 4 and x minus 8. So this is a little simpler, right? If x plus 4 equals 0, subtract 4, x is -4. And if x minus 8 equals 0, add 8, x is positive 8. All right, you go ahead and try this one, pause it, and you can check your answer. So here we know the factors are x minus 8 and x minus 1, and if I set each equal to 0, I get solutions of x equals positive 8 and x equals positive 1. If you recall, there were 3 terms. If the a was not 1, we first had to do a times c. And after we found that number, we found the numbers that added to b. We rewrote the equation, substituting those 2 numbers for the b term, and then we factored it by grouping. So the same thing is going to happen here. So I see that I have 7x squared plus 17x plus 6 equals 0, so it's already equal to 0. So we're going to take a and c, 7 times 6, and we get 42. So I'm looking for what multiplies to 42 and adds to 17. Right? It's a positive number we're multiplying to, a positive number we're adding to, so we're only looking at positives. So 1 and 42, 2 and 21, 3 and 14, and that right there adds to 17. So when I rewrite it, so that's plus 3x plus 14x plus 6, right? We changed 17x into 3x plus 14x. So we're going to group. Out of the first 2, only an x comes out. So we're still left with 7x plus 3 there. Out of the second 2, I could take out a 2, right? A positive 2. So 14x over 2 is 7x, 6 over 2 is 3. So we know this worked because we had 2 7x plus 3's. So my factors are 7x plus 3 and x plus 2. So we're going to set each one equal to 0. So here, subtract 3 and divide by 7. And this we just have to subtract 2. Right, and those were our solutions there. Let's do another one together. So 3 times negative 8 is negative 24. Things that multiply to negative 24, we know it's negative, so it has to be a positive and a negative, like negative 1 and 24, or 1 and negative 24. And we already have the set, right? 1 and negative 24 adds to negative 23. So 3x squared plus 1x minus 24x minus 8. Group it. X out of the first ones. So we're left with 3x plus 1. Negative 8 out of the next. So that's a 3x. That's a 1. So my factors are 3x plus 1 and x minus 8. So we set each equal to 0. Subtract 1 and divide by 3. And here we would add 8. I don't know if you could hear that dog. She's angry about something. All right, you're going to try the next one. You can pause and then check your answer. All right, so we get x equals negative 3 halves and x equals negative 7. The last problem we're going to try is a word problem, and it is a little trickier than most. It's going to be a lot of steps, but that's okay. So here you make a rectangular quilt that is 5 feet by 4 feet. So we know the box here that has the pattern on it is 5 by 4 with an area then of 20. You use the remaining 10 square feet of fabric. So we know we had a total of 20 feet here plus 10 here. So fabric was 30 square feet. To add a border around the quilt of uniform width. So X in every direction. What is the width of the border? So we know the entire quilt, including the border, would have an area of 4 plus 2x times 5 plus 2x. So I'm gonna flip these. I'm gonna write 2x plus 4 and 2x plus 5. So we know area is always length times width. So 2x plus 4 times 2x plus 5 is the total area of fabric of 30 square feet. So what I need to do is I need to turn this into a polynomial on this side in standard form. So that means I'm going to multiply. I'll start with 2x times 2x, which is 4x squared, and 2x times 5, which is 10x. And then 4 times 2x is 8x, and 4 times 5 is 20. I'm going to combine these like terms, but I'm also going to subtract 30 because I know I always want quadratics to equal 0 if I can. So that means 4x squared plus 18x minus 10 equals 0. There's a GCF here. I can divide both sides by 2, right? 2 goes into 4, 2 goes into 18, 2 goes into 10. There's no need to write it on the outside here because I'm not being asked to factor it. I'm being asked to solve it. So 0 divided by 2 is 0. So now we're going to have 2x squared plus 9x minus 4 equals 0. So this is just like the last few that we've done. There's an a value. So 2 times negative 4 is negative 8. We know it has to be negative, so it's 1 positive, 1 negative. Oh, I think I wrote the wrong thing. I don't know why I wrote 4 there. Let's go back for a second. Because that doesn't make any sense. Negative 10 over 2 is negative 5. Okay, let's try this again. Negative 10 has to add to negative 10. Multiply negative 10, add to positive 9. Has to be 1 positive, 1 negative. So like 1 negative 10 or negative 1 and 10. And that's our combination, right? So it's going to be 2x squared minus x plus 10x minus 5. So out of the first two, we have an x. That's 2x minus 1. Out of the second two, I have a 5. Left with 2x minus 1. Sorry if that got too small. But now I have 2x minus 1 and x plus 5. So if I set each of these equal to 0, add 1. Okay, if I have x plus 5 equals 0, x is negative 5. So since I'm talking about the width of the border, I can't have it be negative 5 feet because that would be insanity. So x will have to be 1/2 of a foot all the way around. And that is the end of solving by square roots and solving by factoring.